Today we will discuss about moment of force. What is the moment? It is the turning effect produced by force, turning effect, and is equal to the product of the force and perpendicular distance between the line of action of the force and the point about which the moment is required to find out. Force and perpendicular distance. Suppose this beam AB, its length is L. Length is L. This is force F. The magnitude of force is F. So what is the moment of force F about point A? This is point A. We will find out the moment of force F about point A. So this is perpendicular distance 9 degree. L is perpendicular distance. This is force F. This is force F. So what is the moment about A is equal to? Moment about A. What is MA is equal to? F into L. Clear? Force into perpendicular distance. This is perpendicular distance L. This is direction L. So what is the moment is equal to? F into L. This is clockwise movement. Suppose the force is like this. This is point A, this is point B, this is force F. This angle theta. What is the moment of F about A? Suppose this length L. So L is not perpendicular distance of F. The line of action of F is like this, which makes angle theta with AB. This L is not a perpendicular distance. We will find out what is the perpendicular distance or resolve F. This is F. Okay? So this is theta. Clear? What is this force? F cos theta. This force is equal to F sin theta. So what is the perpendicular distance of F cos theta? 0. Because F cos theta passes through point A. So what is the moment of F cos theta is equal to 0. The distance is 0. F sin theta, this is perpendicular distance 9 degree. This is 9 degree. So what is the moment of F sin theta? Into L. So about area, moment of force about MA. What is MA is equal to? F cos theta into 0 plus F sin theta into L. This is 0. So what is MA is equal to? F L sin theta. Clear? This is moment of force F. F is inclined force. We resolve this F along x-axis, along y-axis. Along x-axis, F cos theta. Along y-axis, F sin theta. That F cos theta passes through point A. So what is the moment of F cos theta? 0. Because the distance is 0. F sin theta makes angle 9 degree. The line of action of F sin theta makes a line 9 degree along the axis AB. So the perpendicular distance between F sin theta and point A is 9 degree. Distance is L. L. Perpendicular distance L, force F sin theta. So what is the moment of F sin theta is equal to? F sin theta into L. This is 0. So what is F is equal to? FL sin theta. Clear? Now, in the figure, suppose this is force F, this is point 1, this is point 2, this point is 3. This point 1, distance d1 from line of action of F. Point 2 is distance d2, perpendicular distance. And point 3 lies in the line of action of force F. Suppose we will find out M1. What is M1? F in d1, force distance, the clockwise movement. This is M2. What is M2? F into d2. Because d2 is the perpendicular distance of force F and point 2. d1 is the perpendicular distance of force F and point d1. 1. Similarly, for 3, what is M3 is equal to? F into 0, 0. Clear? Now, M1 is equal to FD1, M2 is equal to FD2, M3 0. Because the distance is 0. The perpendicular distance is 0. So, it is clear that if the point lies on the line of action of the force, then its moment about that point is 0. Clear? This is the point lies on the line of action of the force. Line of action of the force, then the moment of the force, then the moment of the force about that point is 0. Is 0. Clear? If the point 3 lies on the line of action of the force, then its moment is equal to 0. Clear? This is about moment. Now, there are two types of moment. Types of moment. Types of moment. The moment is mainly two types. Number 1, clockwise movement. Number 2, anti-clockwise movement. Anti-clockwise movement. Clear? Clockwise movement, anti-clockwise movement. If the clockwise movement is calculated, the moment is taken along clockwise direction. Anti-clockwise means the moment taken about anti-clockwise direction. Generally, the clockwise movement is positive, anti-clockwise movement is negative. Clear? What is the unit of moment? Unit. Units of moment. What is M is equal to? F into L, force on distance, force into perpendicular distance. What is the unit of F? Newton meter. Clear? It is a vector quantity. It is a vector quantity because it has a magnitude as well as a direction. What dimension of formula? dimension formula. What is M is equal to F into L. What is M L T minus 2 into L. So M1 L2 T minus 2 is the moment of M dimension formula of M. M1 L2 T minus 2. This is dimension formula for moment. Clear? Now, Varigion's principle of moment. Varigion's principle of moment. This is Varigion's principle of moment. The law states that if a number of cooperative forces are acting simultaneously on a body, the algebraic sum of the moment of all the forces about any point is equal to the moment of the resultant about the same point. Clear? Now we will find out the resultant force. We will show how many forces acting on a body. Then we choose a point. About that point, we will find out the moment of all the forces and we will find out the resultant force. Let P and Q be two forces acting at point A, acting at point A. Clear? R is the resultant force. Resultant force R. Let O is your point. O be the point about which the moment is required to find out. Clear? E and Q are two forces. R is the resultant force. O is your point about which the moment is required to find out. So according to Varigion's principle, the moment of P about O plus moment of Q about O is equal to the moment of R about O. So what is the Varigion's principle? According to Varigion's principle, the moment of P about O plus moment of Q about O is equal to moment of R about O. This is Varigion's principle. Clear? Now I will do what is beam, types of support, types of load. Clear? Beam. This is a beam. What is beam? A beam is a structural member. Member which are length as well as breadth and thickness. But the length is more than breadth and thickness. So what is purpose of beam? What is its work? Its work is to take load. Suppose this is a beam, the support at a B. The two supports, at A and B. It is usually loaded in vertically downward direction. This is load. Double 1, double 2. Clear? Load double 1, load double 2, supported A, supported B. Its length L, suppose this length L. Clear? Now, its main work is, its main purpose is to take load, double 1, double 2. So, to keep the beam in equilibrium position, the reactions developed by the support. These are action forces. I told last class, these are action forces. This is reaction force. What is the reaction? RA. What is the reaction? RB. Clear? So, to keep the beam in equilibrium position, the action and reaction must be equal opposite to each other. That means RA plus RB is equal to double 1 plus double 2. Clear? Now we will discuss about type of support. The reaction depends upon type of support. What are type of load? Now we will discuss about type of support and type of load. Clear? 2 points we will discuss. Number 1, what type of support. Number 2, what type of load. The beam is subjected to loads and supports. The loads are action, the supports are reaction. So what type of load, what type of support. Clear? First we will discuss about what is type of support. Types of support. Number 1. This is mainly 4 types. Number 1, simple support beam. Simple support. This is simple support beam. The beam simply rests on the support. This point A, this point B is also simple support. At A, the reaction RA. At B, the reaction is RB. Clear? This is reaction RA, this is reaction RB. This load double. Simple support. In case simple support beam, the reaction is vertical upwards, the load is vertically downwards. Clear? Number 2, roller support. Roller support. This is roller support. Roller support. In this case, the beam can translate linearly along LX length. Linear means what? Lengthwise. AB. This is load double. The beam can translate. The beam can move linearly. The reaction is normal to support. RA 9 degree. Normal to support. Roller is horizontal, the support is horizontal, so the direction is vertical. Suppose the support is like this. This beam may be to support this. Support like this. Theta. The roller support, but this is inclined to the plane. theta. So what is the reaction? This reaction, suppose this load W, this RB, 90 degree. This is RA, normal reaction. This is also RB, this is normal. Normal to support. So what is this angle? This is 90 degree. This is theta. This is also 90 minus theta. Clear? So this is theta. This is RB. This is theta. This angle theta. This is 90 degree. What this angle? 90 minus theta. What is this angle? 90 minus theta. Clear? Now, resolve this RB along x-axis, along y-axis. Then we will take moment. But this is reaction upwards. RA. This is called RB. This is XB. This is equal to YB. What is XB? Along x-axis. What is YB? Along y-axis. Now, take moment about A. We will apply three conditions. Sigma x 0, sigma y 0, sigma m 0. Three conditions of equilibrium. Then we can solve the problem. Clear? Next, hinge support. Hinge support. Hinge support. This is hinge support. AB. In this case, the beam can rotate, not translate. It can rotate. Suppose this is load W, this is RA, inclined direction. What is this? XA, this is equal to YA. Clear? This is inclined direction. RA, XA, YA. Next, fixed support. Number 4. Fixed support. This is fixed support beam. The beam end is fixed. It can neither translate nor rotate. It cannot move in along x-axis or it cannot rotate. The beam end is fixed. Suppose this is load W. These are two reactions. XA, YA. That means the resultant is inclined. RA. Clear? Suppose this angle theta. This angle theta. What is XA? RA cos theta. What is YA? RA sin theta. Okay? It can neither translate nor rotate. The translation is prevented by developing support reaction in any required direction. Suppose RA is your reaction at A. It has two components. Number 1, XA. What is XA? RA cos theta. Number 2, YA. What is YA is equal to? RA sin theta. Clear? Now, the rotation is prevented by developing support moment MA. This is reaction moment MA. At a three reactions. Number 1, XA. Number 2, YA. Number 3, MA. So these three unknowns can be find out. Clear? Next, I will do what is the types of loading. Now, we will discuss types of load. Number 1, concentrated or point load. Point load. Concentrated or point load. In this case, the load is acting at a point. Suppose this is B, maybe. This is load W. Suppose this length L. In this case, the load is acting at a point. Load is acting at a point and is vertical downward. Vertically downward. Clear? Suppose this B may be the load W is acting at point C. This is point load. We will find out the reaction at A, reaction at B. Clear? The load W is 10 Newton. The length is equal to 6 meter. What is reaction at A? RA. What is reaction at B? RB. Clear? Find RA and RB. Now, what is RA? Reaction at A. Reaction at A. What is RB? Reaction at B. Clear? R and RB. Now, the beam is in equilibrium condition. We will apply three conditions of equilibrium. What are three conditions of equilibrium? Three conditions of equilibrium. What are three conditions? Sigma max 0, summation of y 0, summation of m 0. These are three conditions of equilibrium. This is for non-concurrent and coplanar forces. This is for coplanar and non-concurrent forces. Okay, we will apply these three conditions for this problem. In this case, there is no y component, so this is not applicable for sigma y 0. We will apply sigma max 0, sigma m is equal 0. Clear? Now, first you should clearly understand what is sigma max, what is sigma y, what is sigma m. Summation of x is 0. That means right side force minus left side force 0. This implies right side force is equal to left side force. This is summation x is 0. Similarly, summation y is 0. What is y? Upward force is equal to upward force minus downward force 0. This implies upward force is equal to downward force. This is sigma y 0. Similarly, moment summation m 0. What is summation m? Clockwise moment minus anticlockwise moment 0. That means clockwise moment is equal to anticlockwise moment. Clear? These are three conditions of equilibrium. We will apply these equations in this problem. Clear? Now come to the problem. Now sigma y is equal to 0. Why? Upward force is equal to downward force. Ra plus Rb is equal to W means 10. Equation 1. Clear? Sigma ma. Taking moment out A. What is sigma ma? Taking moment about A. About A. Ra passes about point A. I told you last class, if the point lies on the line of action of the force, then the moment of that force about this point is 0. Ra passes through point A, so its moment is 0. Clear? Now Rb. What distance Rb? L. Perpendicular distance. This is perpendicular distance 9 degree. This is also perpendicular distance 9 degree. So what is Rb into 6? What double into 3? This is 3. This is 3. Clear? Now Rb into 6 is equal to double into 3. What is Rb is equal to? Double by 2. 10 by 2 is equal to 5 Newton. So what is Rb is equal to? 5 Newton. Answer. Clear? Ra. From equation 1, from equation 1, what is Ra is equal to? 10 minus Rb. So 10 minus 5. So what is Ra is equal to? 5 Newton. Clear? This answer. Another question we will do. Last class we have done 21 number of problems. Clear? Okay, now I will give only example for concentrated load. Next question. This is beam AB. Clear? Two loads are given. 10 Newton, 20 Newton. Clear? This is 3 meter. This is 2 meter. This is 2 meter. The question is find Ra, find Rb. That means find the reaction at A and the reaction at B. The question is find Ra and Rb. Clear? Now in this figure, all are y component. There is no x component. So first we will do summation y is 0. Y is equal to 0. Clear? Now RA plus RB is equal to 10 plus 20. 10 plus 30 Newton. Equation 1. This is equation 1. She gave me 0. About a we will take a moment out a. About a RA passes through point A. So its moment is 0. RB. What is RB into? 2 plus 3 plus 2. 7. RB into 7 is equal to 10. 10 into 2 plus 20 into 5. Clear? What is RB is equal to? 20 plus 100 by 7. 120 by 7. You will find using calculator. Clear? You will find the answer using calculator. What is RA? Equation 1. Find RA from equation 1. From equation 1, what is RA plus RB is equal to? What is RA plus RB is equal to? 30. Clear? What is RA is equal to? 30 minus RB. So 30 minus what is RB? 120 by 7. Now LCM 7, 210 minus 120. Clear? So 90 by 7. Newton. Answer is Newton. This answer. Number 2. Next theory. Distributed load. Distributed load. UDL. UDL. Number 2. Clear? One is point load. Number 2 is UDL. Load is distributed uniformly over the entire beam. Suppose this is beam. AB. AB. This is UDL. Clear? W Newton per meter. Suppose this is L meter. L meter. What is the load? W. This is total load W is equal to small w L. It is acting at the center of the beam. This is L by 2. This is L by 2. Clear? The total load is uniformly distributed over the entire beam. In this case, the load is uniformly distributed over the entire beam. How to find the total load? The total load is find out by multiplying the UTL with length. That is W into L. And ejecting at the CG of the beam. CG means for length, the CG is L by 2. This length L, its CG is L by 2. Clear? The load ejecting at length L, so it's half L by 2, L by 2. This point C. This is point C. Clear? Now we'll calculate what is RA, what is RB. Clear? In this case, the load is uniform distributed over the entire beam. Hello? The total load is find out. The total load is find out by multiplying the UDL with length. With a length. With a length. And where that load ejecting? At the CG and ejecting at the CG of the loaded portion. Here, loaded portion L is CG L by 2. Total load W L. Now I will do some example to understand this theory. Clear? This can also explain in this way also, in this figure also. This is RA, RB, A, B. Clear? Suppose this length L, load W, all load are W. Clear? This is figure. In this figure, this load is W Newton per meter. Length L. This looks like a rectangle. What is the area of the rectangle? Length to breadth. In load diagram, the total area is equal to total load. In this figure, what total length? L. Total load W. What is the area of this rectangle? W to L. What is CG? This is CG of the rectangle. This is W. Small W into L. This is L by 2. This is L by 2. Clear? This is also UDL. This figure is also same as UDL. Load W, length L. This forms a rectangle. Its area is equal to W L. This is total load W. And ejecting at the CG of the loaded portion. What is CG? For rectangle, where two diagonals cross each other, that is CG. This is point G. What is CG? Where two diagonals cross each other, that is CG of the rectangle. At this CG, the load W is acting. That means this is L by 2, this is L by 2. Very clear? I'll do an example. Suppose this is a beam. Clear? This is UDL. Load is given here. This is reaction RB. This is reaction RB. Clear? This is point A. This is point B. This is 2 meter, 1 meter, 3 meter, or 4 meter. Clear? Suppose this is equal to 10 Newton per meter, 20 Newton, 30 Newton. The beam is loaded as some figure. This portion is UDL, this is point load, this is point load. What is reaction at A? What is reaction at B? Clear? Let RA is equal to reaction at A. What is RB is equal to reaction at A B. First, make load calculation. Now, this is point load, this is point load, this is UDL. We'll convert this UDL into point load. Now, 10 Newton over 4 meter. This is 10 into 4, 40 Newton. Clear? What this length? 2 meter. This length? 2 meter. Clear? Now, we'll do, first we will look at sigma y, because there is no force in x-axis. So first, summation y is equal to 0. Upward force is equal to downward force. Clear? What is upward force? RA plus RB. What downward force? 40 plus 20 plus 30. Clear? This is equal to 90 Newton. 90 Newton is equation 1. So RA plus RB is equal to 90. Clear? Now, take moment of A. Taking moment about A, that is summation M is equal to 0. Clear? About A, this is RA. Clear? This is RB. This is 2 meter. One meter. Clear? Now, about A, sigma is 0. About A, RA passes, so its moment is 0. Next, what is RB? RB into 4 plus 2 plus 1, 7. RB into 7 is equal to 40 into 2 plus 20 into 4 plus 30 into 6. Clear? We can make calculate and find out RB. Answer. Next, from equation 1, what is RA plus RB is equal to? What is RA plus RB? 90. This is question 1. What is RA? 90 minus RB. You can find out answer. You can make calculate and get the answer. Clear? Next, number 3. 3. Uniformly varying load. Clear? Number 3. Uniformly varying load. Varying load. Suppose this is beam AB, A, B, length L, length is equal to L. We'll find out how to calculate in this case. In this case, the load varies uniformly, changes uniformly. Suppose they start from 0, W, 2W, PW. Suppose total load W, small W. Suppose for length the load is 2 Newton, another 2 meter length 4 Newton, another 2 meter length 6 Newton. Load changes uniformly. Finally, it makes a triangle. Load starts from 0, ends at double Newton per meter. Clear? Double Newton per meter. So this forms a triangle. We know load diagram. The area of the figure is equal to total load, and total load is acting at the CG of the load diagram. This is triangle. It's a CG. So in this case, suppose this is your G point. This is equal to CG of the triangle. So in this case, load is acting here, W. What is the area of the triangle? Half into base into height. Half into base, L, height, small W. So what is this? This is equal to half double L. This will acting at the CG of the loaded portion. What is CG? I will detail explain you the CG of the triangle, rectangle in center gravity chapter. I'll give just a formula. This is equal to L by 3 from the base, H by 3 from the base. This is 2H by 3 from the vertex. In this triangle, this is base. The load represents base. The length represents height. So in this case, CG. The CG point is L by 3 or H by 3 from the base, 2H by 3 from the apex, or 2L by 3 from the vertex. Clear? In this case, the load varies uniformly over the entire beam. Varies uniformly. Uniformly varies. And the total load is found out by calculating the area of the triangular diagram. And is acting at the CG of the load diagram, triangular load diagram. Clear? What is CG? L by 3 from the base, 12 by 3 from the vertex. This is base. What is this? This is your base. Base. Clear? This is constitute height. This is vertex or apex. Clear? In this triangle, the CG is L by 3 from the base, 2 L by 3 from the vertex. Okay? Next class, I will do some problems relating today's theory. Clear? Thank you.